Welcome to the Tentry Intelligent Infrastructure Webcast. I'm Clay Ryder. In this webcast, we will explore how intelligent infrastructure can provide a different experience by delivering new granularity and more for SQL Server workloads. Today, we will hear from a guest expert, offer some additional resources for your benefit, and have an open Q&A session at the end. If you'd like to ask your question during the presentation, please enter it into the Q&A or chat box at the bottom of your screen, and we'll queue it up for discussion later in the program. Without further delay, I would like to welcome our guest, Sean Meyers, to the webcast. Welcome, Sean.
Well, thank you for having me, Clay, and welcome to the entire audience. Appreciate you taking the time out today to join us.
Oh, and thank you for being here today. Please tell our audience a little bit about yourself.
So I'm Sean Meyers. I've been an IT guy since '93, a deep background for SQL Server for 24 plus years now. My current role is field CTO at Tentry. I started here in late 2019. Before that, I was a principal architect and the practice lead for the SQL Server practice at Brick Technologies for 8 years. And then I started getting exposure to Tentry in 2015. I met Rob Gerard at a VMware SQL Server experts group. So VMware has a group of basically SQL Server DBAs who are a panel. They ask questions about future, how VMware should work with SQL Server, this kind of stuff. And Tentry was sponsoring one of these events, and VMware invited me to, and that's where I met with Rob Gerard. And after that, Rob Gerard and I have been great friends. But also, we've been speaking at multiple different events, including VMworld and SQL Pass Summit. And plus, I've also spoken at VMworld individually and at SQL Pass Summit and SQL Saturdays, VMUGs, and many, many other type of industry events. I am a VM expert. I have a VCP and an MCSE.
Well, thank you, Sean. One challenge faced by data centers is the need to support an ever-growing number of databases, in particular those running on Microsoft SQL Server. When databases go down, so do businesses, and these interruptions, whether momentary or longer in duration, can significantly impact operations. This threat is not limited to production or business-critical databases, as the loss of access to DevOps, DevTest, remote copies, etc., can still cause significant productivity slowdown and loss of business agility. Sean, how would you describe the relationship between enterprise storage solutions and DBAs?
Well, thanks, Clay. One of the things is the DBAs and storage teams tend to have been at odds at each other for years, and Tentry is now trying to work to solve some of those issues. Look at the picture on here. This picture is a 10-year-old picture on the screen. The thing on the left is a 1 gig hard drive, and the thing on the right, of course, is a 1 gig hard drive. Nowadays you can get that to be 128 gig in the same size. So storage has changed a lot. It's gotten much smaller, it's much faster, it uses less space, and yet how we DBAs consume storage is still the same. All the changes in storage, yet the process of presenting storage to a SQL Server database engine has not changed one bit.
Well, Sean, given the importance that databases play in most any organization, the reality is that their contents must be stored somewhere. What are the common approaches to database storage today, and are there any alternatives? And what are the pros and cons of each?
Sure. At the end of the day, is sometimes it's more of a language barrier we have. DBAs talk about transaction and transactional speed, and latency and our wait stats and impacts of that, versus infrastructure teams and storage vendors want to talk about IOPS and throughput and kind of stuff. And so we have different languages and how different parts of the storage stack relate to each other to determine how things perform. End of the day, neither of those conversations is the correct one. The correct one, of course, is the impact to the end user. I.e., not having enough IOPS will lead to slower transactional speed, which leads to obviously slower screen refreshes. So we need to stop having those conversations about that and try to figure out how we talk the same language. And at the end of the day, it's about the end of the application. So each SQL Server file has different I/O needs. The log file is different from the mass, the MDF file. One has data, one has logs. The write patterns to it, the block sizes are different, and how the access is done. So we need to understand those. So in the old days, we always created different disk pools by database file type. So the log file would tend to have a RAID 10 disk pool, and the data files would have RAID 5s. Then we moved to all flash systems, and what happened is we started dumping everything into one together. We still have different drives or different VMDKs, in your for your database servers, but both of those drives were all in the same LUN, the same storage unit. It's all together. Even though I have different I/O needs, everything was treated equally into one giant pool.
Well, years ago, at various points in my career, I was considered the database guy. And I can tell you from firsthand experience, I knew that regardless of how the databases were implemented, the number one complaint I received was that they were not fast enough. Make it faster. I have work to do, was the common refrain. I'm sure that these statements are still apropos today. What is a different approach that organizations could take that would improve the database experience for both administrators and end users?
Sure. So we have a standard infrastructure. We've always had LUNs or volumes or whatever you want to call it on the storage unit. And then we placed virtual machines into each one of those into that LUN. And we actually stacked multiple virtual machines. So at Tentry, we actually created a process of intelligent infrastructure to extract just that one VM from that LUN level. So then I can manage it at the LUN level. The problem, of course, is I still had a bunch of databases inside of there. So even though I was treating the I/O patterns for that virtual machine, all the IOs were shared across all the databases and it was all mixed together. So now what we're doing, we're taking the database out from the VM level and have its own level. So now we're going to be able to manage each database at the database level. So even though I might have 25 to 50 to even 1,000 databases on one single SQL server, I can manage my IO and throughput for each database on an individual level. And that includes QoS and reserving resources.
I see. So, what you're saying is there's a need to take a new approach to the challenge. Intelligent infrastructure views the solution from a completely different perspective in that it's database centric as opposed to storage unit centric. Hence, you have a level of granularity that enables you to protect and troubleshoot the performance envelope for each database as opposed to a LUN or a volume. However, I do note that this presupposes the database server is within a virtualized environment. Is it possible to take this approach for bare metal or physical database servers as well?
Yes, absolutely. So the intelligent infrastructure where we pulled the virtual machine out still applies to a physical machine because I don't need to have the database to be on as a VM. The database, still resides on the SQL server. I can still pull that database from where it's at on the physical machine and put it into SQL integrated storage, which allows me to have the database where I want it at. And now I can still control that database at the database level. So I can now, in each file, I can actually have metrics and monitoring for that.
Well, Sean, that's quite remarkable, and I suspect a significant departure from the current experience of most database and storage administrators. It seems that SQL integrated storage changes the administrative model and indirectly the end user experience. What are some of the key features of SQL integrated storage, and how do they fundamentally change the SQL Server equation in today's data center?
Sure, there are many different things. The first thing I like to talk about always is visibility. Now, everyone has databases and SQL servers, and when you look at things, you can go see your file stats inside of SQL Server. It's called DMV virtual file stats, and that can tell me my reads and my writes and my latency I'm seeing on that. However, those numbers are tracked per since the last time that the SQL Server has been restarted. So if I have a 5-minute slowdown, it's mixed in with all the rest of the time since the server has been up. Same thing with OS numbers. I can go capitalize OS numbers. However, I can't capture IO at per file in the OS. I tend to file by drive. So with the visibility in the Tentry VMstore UI, I actually have the ability to look at each individual database and each individual database file and look at deep metrics for that. I can go look at basically how fast it's going, what my throughput, my IOPS, my latencies, and then also with that determine if the latencies are coming, is it coming from the host layer? Is it coming from the OS? Is it coming from the storage layer? And I can go drill down quickly and determine where my slowdowns are at in real time, not going back, looking at aggregate numbers. I actually get real-time numbers. And then when I have issues, I can definitely go in and look. Or my favorite one is you had a slowdown 2 hours ago. So it's like person's complaining about it's really, really slow, it's doggy, blah, blah, blah. They finally open a ticket. By the time it routes and gets to you and your desk and you're the DBA trying to troubleshoot this, everything is fine. Everything's running support, in metrics, all your SLAs are being met, and you can't figure it out. You try to look through, of course, again, if you have counters since, last time server's been rebooted, those are all meshed together. Trying to figure out what the pain point was. Well, now the visibility here, I can now stack all my SQL Server databases in one single pane of glass. I can look at them all and see 2 hours ago what was going on, which one was my top contributors, was my one specific database seeing a slowdown, or one big database causing so much I/O it was impacting others. Those questions you always have. Here, I have a single pane of glass now to show this all to you. Performance-wise, so the Tentry VM Store with SQL integrated storage has some great, amazing features for how to guarantee performance. Each database is assigned its own I/O channel, and based upon its utilization for the past 6 hours, performance reserves are set aside for that database. So when somebody else is writing a horrible query that's doing a massive join across, gobs of tables and all kinds of just silly things in the query that take up lots and lots of I/O cycles, or I/O requirements. In a single LUN model today, all databases are impacted by one really bad performing query for that one database. So the database is still impacted, but all other databases on that same LUN are also impacted. With the reserves and processes and the guaranteed channels per database, all other databases would not be impacted with SQL integrated storage. So I can guarantee performance for each database. So I have one offending one, it may get throttled or slowed down, but I still have great processes here. Plus, we have QoS functions. So we have auto QoS to guarantee that things are running properly. Or if I want to prioritize one or two really critical workloads above other ones, I can drill into those and set manual QoSs to guarantee the performance meets my SLAs or my expectations for my end users. Data management. There are so many things inside data management. I can spend just an hour talking about this. If you get me after hours and we're talking about things, I can go on and on and on and on and geek out about how cool some of this stuff is. So snapshots and cloning for databases. These are snapshots we're talking about done at the storage layer. SQL Server snapshots and VMware level or even Hyper-V level snapshots, those both are performance impacting, meaning the longer those snaps exist, the slower your performance is. Storage layer snapshots, the longer they live, has zero impact on performance-wise. And also the snapshot process is a zero stun, no impact production process. In other words, I can take a snap and not slow down any transactions whatsoever. And so you can have whatever transactional metric you want up there measuring things, and I can take a snapshot every 15 minutes, and you cannot tell me when I was taking my snapshots because there's no impact to SQL Server. So these snapshots, what can I do with them? The best things, of course, are going to be protection intervals. I can do quick recovery with them, meaning if something happens to production databases, I can bring a snapshot back in seconds versus a restore takes minutes or hours or even days, depends upon how complex things are. Your RPOs and your RTOs regarding the amount of data loss will determine that. But one of the best case use cases is if a developer is in production and happens to, why without developer production? We don't know, but somehow they got in there. So a developer was in production, they were trying to fix something, they did an update statement without a where clause. Oops, I just overwrote a whole bunch of data. So with a snapshot, I can mount that snapshot to that same SQL Server as a different database name, in under 2 minutes. So from the time I realize what's going on, 2 minutes later, I have a copy of that data the way it was beforehand, and then I can just do a simple join query to go update back to production. So production is now cleaned up from that snapshot. The good thing about snapshots in this process, they don't replace your backups, but they're giving you a brand new tool in your toolbox. You can do all kinds of really cool things with that. And that's for your protection side. And then the cloning process comes up. So cloning comes down to allowing us to make copies of that same database to either A, offload my maintenance for my database systems, or B, to refresh my dev or QA systems or any kind of non-prod lower tier systems I need to test on. So offloading maintenance, for best practices wise, you should be doing a full backup of each SQL Server database and doing a CheckDB integrity check every single night if possible. Most people don't have a maintenance windows large enough to allow for that to happen. So what happens is, they skip those steps or they try to offload it some other ways. However, if you go read Paul Randall, and he's one of the guy who wrote CheckDB for Microsoft and SQL Server, one of the best SQL Server consultants out there, talks about if you're doing a CheckDB, you have to use the exact same blocks. So if I do a CheckDB on a different database, on a different server, I'm not doing that. With a clone process, when I first make the clone, what it is, I actually have two database servers pointing to the exact same set of blocks. So if I run CheckDB on that, I am using the exact same set of blocks my production system is using. So that allows me to do offload CheckDB and or my backups off to a secondary server, so I'm not having a performance impact to production workloads doing maintenance windows. Same thing with development-wise. Now imagine you have 12 developers. Every developer wants their own set of databases, their duos work on. However, we have these shared environments because we don't have the resources or the bandwidth to make 10, 12 different copies of the system. Not to mention, most developers are working on multiple different projects. So they have, 2 or 3 copies of the database themselves, one for this branch, one for the next version branch, this kind of stuff. Plus we have all the QA, we have the testing, we have multiple different facets where we do patch testing beforehand. So we have multiple different environments, and it takes a lot of time to do backup, restore, or copy processes. Or if I'm using legacy storage with LUNs, I'm now cloning and snapping at the LUN level, and so I'm now bringing over a full LUN and all the databases on that at the same time. If I only want to worry about one of them, just worry about one of them. So with this SQL integrated storage, we can now snap or clone at an individual database. So only bring that one database over. And since it's a snapshot, all the blocks are still the same until we start doing changes, i.e., if I make 12 copies of a 2 terabyte database, I still only have basically a 2 terabyte database on there, plus I have my dedupe and compression. So I may only be using 600 gig to hold 12 copies of a 2 terabyte database. So those are some great, fantastic things. Again, I can go on and on and on about this, but we need to move on. Improve workflows. So the developers love to write their own code and be able to self-service themselves. So there's a full RESTful API and a PowerShell toolkit that's available. So now we can run all these snapshots, these clones. We also can look at some of the data on the throughputs and numbers from these APIs, and it allows me to now give the developer the rights to refresh their snapshots on their demand when they want to. No more opening a ticket and having a DBA, or then the DBA opens a ticket to the storage team creates a snapshot on the LUN, and then we represent it to the VM, and then we do some more triggering and stuff, and then now we've got to refresh. This is done in seconds and can be done on the fly as they need to. The most difficult process of this automation is now managing for sprawl, because it becomes so easy, people start creating more and more systems. The good news is the UI and the visibility we talked about first gives us great insight to where all these things are at and where the space is being used, so we can figure out quickly who's using it. But yeah, the workflows are pretty fantastic. It allows you to do many, many things. Simplicity. When I first started talking about this, I wanted to leave my whole thing about simplicity just completely blank, because it's so simple, I don't need to explain it. The UI and how this process works is quite simple. It's fairly easy to figure out. The auto QoS process, it's automatic. It takes care of itself. It basically determines what the usage pattern has been and makes sure it reserves enough resources to maintain that usage pattern. So when usage pattern or something else changes, it doesn't impact my current database. Lots of different things. So basically, plus the UI is really easy. Anybody can sit around clicking over for a while and figure out how to do what they want. They can go use the UI, find out what's causing the problem, from a storage problem, from latency or throughput, figure out which database is using the most I/O, do a trend report to see that, hey, every day at 3 p.m. we have a massive spike in throughput on one database for 5 minutes. Hey, we can go figure out quickly that this is an offender that causes slowdowns for everybody else. It's actually a report that doesn't even run anymore. This kind of stuff. And it's very easy, intuitive to work through. And of course, analytics. So one of the biggest advantage, with the VM store we have is deep analytics. A lot of these data points we're talking about are stored for 3 years in here, and which allows us to look at how much performance we're using, because obviously each array has a limitation on how many IOPS it can deliver, plus how much storage it has. We can look at training analysis on what your growth rates have been, and then also what your on A, storage space, and B, IOPS and throughput and performance-wise, and figure out when this array is going to run out of space. Plus, we can combine it with other ones to figure out which ones are the biggest users. We can do it by database. We can do it by virtual machine. We can analyze it in multiple different facets. And these deep analytics allow us to make predictive answers and help you decide what you need to be doing with things. Training for your future and showing what's next is what's very, very helpful.
Would you share with us some examples of how intelligent infrastructure has changed the delivery of IT services?
Sure. I mean, recently I was doing a demo and talking to a customer, and once I showed them how they're a very heavy use of development, and they've got many processes in place where they're refreshing systems on a regular basis, and it takes a lot of time and a lot of management. They've got a lot of wheels and a lot of basic duct tape holding everything together. And after I showed the demo, this first question was, when can I have it? He wasn't asked about price, didn't ask about anything else. He wants to know when I can install it. It was that that much of a change for him, which goes to the next one. George Crump is the chief steward at Storage Switzerland. Basically, after he saw a demo of this, his answer is, this is a complete game changer. End of the day is there's a lot of tasks that we can remove the administrative overhead for your SQL Server storage administration tasks by up to 95%. When I was a consultant, I worked for a company that had over 1,200 SQL servers. And each SQL server basically had between 6 and 15 drives on it. And each drive, of course, has different space requirements. And as databases grew, they'd have alarms and alerts saying, okay, this drive is now at 90% capacity. We need to go grow the drive. So one of the DBAs, this person's job, a quarter of his every single day, so 2 hours a day, basically, he spent looking at the report, finding out which server was at, find which drive was running out of space, opening a storage ticket, following up with the ticket of the storage team. The storage team then, of course, could do that, and then he'd have to go back in and then go into Windows, grow the drive, and then make sure everything's clear. But 0.25 FTE, so a quarter of a full-time employee, was spent just doing storage tasks on this organization. Versus all those things all go away with intelligent infrastructure.
Well, thank you, Sean, for highlighting for our audience how intelligent infrastructure delivers a different experience in supporting databases compared to standard infrastructure. For those who would like to learn more, what would you recommend?
Well, first, schedule a personalized live demonstration with an expert. You can have me or one of the many other people at Tentry who are very familiar with this system. Talk to your sales rep. Your Tentry team will be there to help you. Feel free to reach out and talk to them. There's a tech brief on the link here. And then also, I've started a blog post series. So basically we have just part 1 up so far, but there'll be 7 parts of the series. And each part will go into, of that last 2 slides ago when we had these 6 different main sections, in depth on each one of those and basically how it works and how to utilize it for you. So these are great resources for you to go find and learn new things.
Okay, our first question asks, can snapshots be used if there's a need to do a restore of a given database if the backup, that is the BAK file, is unavailable?
Correct. So basically, yes, we can take that there, but of course, it's a point-in-time snapshot, just like your BAK file is, meaning when the back file was created, the snapshot also is a point in time. And I cannot apply logs to things I restored from snapshot, versus a BAK you can restore log files continuously onto.
Okay, our next question asks, are these capabilities you discussed available for IntelliFlash?
Currently, they are not. They're only in the VMstore family. And I do not know. One of the other questions is, I believe, is it on the roadmap? And I am not part of the engineering team enough to know if that is where that's at. I do not know for sure, but we can definitely find out the answers.
Yeah, we'd be happy to follow up with you on that. Another question asked, does VMstore support a retention policy for snapshots? For example, deleting snaps that are more than 1 week old.
Yes. So if the snap is not being used for something, so the cool thing is it's very intelligent. So in other words, if the snapshot has been represented, so say you take a snapshot every hour, you have an issue, then you go ahead and now take a snapshot from the last hour, present it off to a different SQL server because you need to go test something out. And then you continue on, leave it there for 2 weeks, and you continue on and taking a snapshot every hour. Well, the retention policy can go through and get rid of all of the older snapshots for you automatically, but that one that you took 2 weeks ago is still in use for a database presented somewhere else, will not be touched because it's in use. Until you actually remove that one database, then that snapshot will automatically be cleaned up as well, unless it's a manual snapshot. Manual snapshots need to have a manual delete process.
Another question asks, doesn't the performance get impacted when developers are using the same path to the storage as the production workload?
Typically speaking, no, because each individual database, even though it's using the same set of blocks, the path to it is a separate path for each individual database. So it allows us to have 12 developers using the same storage array as the production database is residing on and not have a performance impact. And still provide sub-millisecond latencies for each of those databases.
Another question asks, can I get a copy of the slides? Oh, yes, of course. We will provide you with the slide deck as well as replay information should you wish to share this webcast with your colleagues. Well, thank you all for your questions. Our time together is coming to a close. I'd like to thank today's guest, Sean Meyers, a field CTO for Tintri.
Well, thank you. It's been great to be here, and I love sharing how cool this tool is and doing live demos. So make sure you reach out to us if you want to learn more.
Yeah, as well as all of you in the audience for participating today. Remember to check out the other resources we've discussed, and if you have any further questions, please contact your local Tintri representative. Be sure to join us next time when Frank Shepard will talk with us about how you can change your administrative experience by proactively using analytics provided by intelligent infrastructure. For all of us at Tintri, I'm Clay Ryder, and thanks for participating. I hope you found this time to be well spent.